The cloud completely changed how we store and process our data. It's the engine behind so many of the apps and services we use every day. But as our world becomes more connected with smart cities, autonomous cars, and billions of IoT devices all generating massive amounts of data, the cloud alone is no longer enough. There's a new player in town, and it's called edge computing. In this video, we'll explain what edge computing is, why the cloud has its limits, and how the edge is enabling the real-time intelligence systems of the future. Ready? Let's dive in. First, let's quickly recap what cloud computing actually is. Think of it as a giant, centralized brain. When your phone, laptop, or smart speaker does something, it often sends data over the internet to massive data centers owned by companies like Amazon, Google, or Microsoft. These data centers have immense processing power and storage. They handle everything from your photo backups and streaming services to complex business applications. This model is fantastic for storing huge volumes of data, running websites, and providing services that can scale to millions of users. But it also introduces a fundamental problem: distance. Sending data back and forth to a faraway cloud takes time, and that delay is called latency. For many applications, a little latency is no big deal, but for others, it's a deal breaker. This brings us to why the cloud isn't always enough. When data has to travel hundreds or even thousands of miles to a data center and back, several issues pop up. The most obvious is latency. This delay can make real-time applications feel slow or unresponsive. It also consumes a ton of network bandwidth, as massive streams of raw data have to be constantly uploaded. Plus, sending sensitive data over long distances increases privacy and security risks. For applications where split-second decisions are critical, like an autonomous car needing to brake instantly or an industrial robot on a factory floor, the delay from the cloud is simply too long. Milliseconds matter, and in these scenarios, the cloud cannot respond fast enough to be reliable or safe. This is where edge computing changes the game. So, what exactly is edge computing? It's a simple but powerful idea. Instead of sending all data to the centralized cloud, we move the processing and intelligence closer to where the data is actually created. This is what we call the edge of the network, right near the sensors, cameras, machines, and users. By placing small, powerful computers at the edge, we can process data locally almost instantly. Only the important results or summaries, like an alert or an insight, need to be sent to the cloud. The immediate result is a massive reduction in latency. Decisions happen in real time. It also frees up network bandwidth because we're not sending a constant fire hose of raw data. And since sensitive data can be processed on site, it enhances privacy and security. It's all about making decisions faster and smarter, right where the action is. Now, you might hear a few different terms, so let's quickly compare them: cloud, edge, and fog. Cloud computing is the big, centralized powerhouse. Great for heavy-duty analysis and long-term storage, but it's far away. Edge computing is the opposite. It's local, super fast, and responsive, right next to the device. Fog computing is often described as a middle layer that sits between the edge and the cloud. It helps to organize and process data from multiple edge devices before sending it on. But the key takeaway is that modern systems don't force you to choose one. The most intelligent approach is a hybrid model. The edge handles immediate, time-sensitive tasks, while the cloud takes care of the big-picture analytics and long-term storage. They work together, each playing to its strengths. Let's look at some real-world examples where edge computing is making a huge impact. Think about autonomous vehicles. A self-driving car can't wait for instructions from the cloud to avoid a collision. It needs to process sensor data from its cameras and LiDAR instantly. That's edge computing. Smart cities use edge devices in traffic lights to analyze traffic flow and adjust signals in real time, reducing congestion. Drone swarms can coordinate their movements locally to perform complex tasks without relying on a central controller. In smart factories, edge computing on machines can predict maintenance needs before a part fails, preventing costly downtime. And in healthcare, wearable sensors can analyze a patient's vital signs locally and send an immediate alert in an emergency. All these incredible innovations depend on local, real-time intelligence. Looking ahead, edge computing is a critical foundation for next-generation networks like 5G Advanced and 6G. The future of connectivity isn't just about being faster, it's about being smarter. Future networks will tightly integrate communication, computing, and artificial intelligence into a single, seamless system. This will create networks that can adapt, learn, and respond intelligently to the needs of applications and users. The edge is where this intelligence will live, turning our networks from simple data pipes into distributed, thinking platforms. So, while the cloud is incredibly powerful and will remain essential, it's not the whole story anymore. For a truly real-time, intelligent, and connected world, we need to bring processing closer, faster, and smarter. That's the promise of edge computing. If you want to keep exploring the future of networks, edge intelligence, and connected systems, make sure to subscribe to our channel. Thanks for watching.